All right, good morning, everybody. This is going to be our last session for volcanoes. We're going to cover Explorer number 4. Let's take a look at what our essential question is. What are some results of volcanism? Okay, so here's kind of our guiding question there. So let's go ahead and start our notes over here. Roman numeral 1, or actually first, I'm sorry, let's go ahead and erase that, draw our lines. And let's see, today's date is the 2nd, 10/2/23, Monday. The essential question. What are some results of volcanism? As always, I like you to be in the habit of scanning your document and seeing what the main sections might be. So we are going to cover different types of lava. We're going to talk about types of pyroclastic materials. So these are things other than lava, but still coming from the volcano. I know most of us think just lava, but there's other things. We're going to cover the different types of volcanoes out there. So I can already see three main kind of sections here. We're going to talk about calderas and fissure eruptions. And it looks like we're also going to be covering volcanism as a constructive and destructive force. All right, so what are the benefits and the drawbacks of volcanism? All right, so let's run back up here to the very top. And let's go ahead and shut some things down here so our pages are a little bit shorter. Roman numeral 1. Types of lava. Of course, we know the difference between magma and lava. If you don't make sure you understand the difference, magma is subsurface molten rock, and lava is magma that's reached the surface. It looks like we have Pahoho. Pahoho is a basaltic lava with a relatively low viscosity. Pahoho flows quickly and sometimes hardens into rope-shaped bands of basalt. It usually forms where lava flows down a gradual slope. And second paragraph, you can see that there's another form called Aha. This is jagged basaltic lava that forms when the gas content in the lava is high. This causes increased viscosity but lower density. As lava cools, it solidifies as small blocks on the top of the main lava flow. As lava usually forms where the lava flow over steeply sloping surfaces far enough from the volcano vent to have cooled significantly. It solidifies as small blocks. Okay, and then you got blocky lavas. Formed from the eruption of intermediate magma, something in between those two. And criteria which form into blocks less than 1 meter in length. All right, well, let's go ahead. Looks like we got three different lavas we want to talk about. The first one is going to be called Pahoho. These are all Hawaiian words. It is basaltic. Basaltic lava versus something like felsic, right? It has with low viscosity, so it's very thin with low viscosity. That means it's going to flow easily, right? Often seen as rope-shaped bands. okay? And often you'll see this where lava flows down a gradual slope. The second type, letter B here, is going to be the Hawaiian word has an apostrophe in it. And what do I want to say about this one? This is jagged, not rope-like. This is a jagged type of, again, basaltic lava. High in gas content. Gas content in the lava is high, right? Okay. Due to high gas content. Okay. As, let's see, this causes increased viscosity but lower density. Therefore, increased viscosity, it's a little thicker, but decreased density. Okay. As lava cools, it solidifies as small blocks on the top of the main lava flow. Okay. Usually forms as small blocks on top of the lava flow. Okay. The third type of lava that they talk about, paragraph 3, blocky lavas. This will be letter C, okay? Letter C. And blocky lavas. They form from the eruption of intermediate magmas. Okay, they are more viscous and cool into larger blocks than which form into blocks less than 1 meter in length. Okay, so we're going to say here it's an intermediate lava or magma. Forms larger blocks. If the was less than 1 meter in length, then the blocky lavas, we can presume, are greater than 1 meter in length. Greater than 1 meter in length. Okay. Of course, you have a nice video to go along with that. Oops, let's clear that. And let's be moving on here. Okay. So take a look at this volcano in Hawaii here and kind of help round out your understanding of this. And we're going to now go into the types of pyroclastic materials. This will be Roman numeral 2. Types of pyroclastic materials. So now we're talking about things other than lava. In an explosive eruption, lava does not simply flow from a vent. Instead, exploded silica, ash, and volcanic gas erupt out of the volcano. These pyroclastic materials may also cascade down the slope. Okay, so there's some interesting points here. These pyroclastic materials, what are we talking about? We're talking about silica, ash, volcanic gas. They can erupt into the air. They can also cascade down the slope as pyroclastic flow. There are many different types of pyroclastic materials. Okay, so first, before we get into this, let's say types of pyroclastic materials other than lava flow, right? They can include things like silica, ash, volcanic gases. Right? I could see a question that says exactly what are pyroclastic materials. They can explode into the air or flow down the sides of volcanoes. And we would call that a pyroclastic flow. Okay. So there are many different types of pyroclastic materials. Let's go ahead and jump into those. We'll say this is letter A. We've got collectively, right? And I'm just putting collectively known as tephra. Collectively known as tephra. Volcanic ash and dust are the smallest. Okay, so maybe what we do here is we can say the smallest include ash and dust, which is bad, of course. We talked about how destructive this can be to your lungs and to engines, like in jets, right? Volcanic ash and dust are all particles that are smaller than 2 millimeters in diameter. So they are less than or equal to 2 millimeters in diameter. Okay, so they're giving us a little bit of a criteria on how to judge one type of tephra from another. The second type is called lapilli. Okay, so this is going to be number 2. Lapilli. Small balls of volcanic glass, 2 to 64 millimeters in diameter. Okay, so small balls of volcanic glass, 2 to 64 millimeters in diameter. Okay. Tephra larger than 64 millimeters in diameter are known as volcanic bombs or volcanic blocks. All right, so let's go ahead and put down for number 3 here. Larger than 64 millimeters. We have 2 different things. We have volcanic bombs. You've probably seen these in movies, right? And you have volcanic blocks. So let's first address the volcanic bombs. They are molten for most of their flight, so they take on a rounded shape as they fall. Bombs that are still molten when they hit the ground will flatten. They're sometimes referred to as cow flops. Okay, interesting. Glad they didn't say cow patties. Volcanic bombs. Molten most of their flight. Referred to as cow flops because they flatten on impact with the ground, right? Now, the other thing here, and let's just go ahead and make sure we understand there's this thing called volcanic bombs, and letter B, we have these volcanic blocks. And what can we say about volcanic blocks? They are solid throughout their flight. They will usually have a more angular shape. Okay, that's worth understanding the distinction. Solid. Throughout their flight, usually angular shaped. Okay, usually angular shaped. And now we have another thing. Pumice is a form of volcanic glass. That's an interesting thought. People use pumice stones to exfoliate the skin off their body, right? So this is going to be number 4. Pumice. A form of volcanic glass, comma. As felsic magma travels through the air, it cools quickly. So here, this also is interesting. It's felsic magma. As felsic magma travels through the air, it cools quickly enough to trap bubbles of gas inside it. Aha! That's why it's so light. That's why it floats on water. These trapped gas bubbles give pumice a very low density, which allows it to float on water. Okay, felsic magma travels through the air. Cools quickly, therefore trapping bubbles of gas inside it. Therefore, it floats on water. Pretty interesting stuff. And they've got some images over here that you can take a look at. All right. Okay, now